Okay, so hello and welcome to our video lecture for today. So this is the phase 1 of our lecture on the next chapter, which is the geomorphic processes. So as a learning objectives, at the end of this chapter, you will be able to, number 1, distinguish exogenetic and endogenetic processes, and then recognize the different geological agents. Then explain the denudation processes. So we as well describe the geomorphic processes and then illustrate the denudation, degradation, and aggradation process. So from this, we are going to list triggering factors in physical, chemical, and biological weathering. So we're going to also list and describe endogenetic process, and then summarize the scope of geomorphic processes through a diagram. And then we're going to give examples on physical, chemical, and biological weathering process. So as an objective, you will also be able to recall different types of chemical weathering and then explain chemical alteration of rocks into minerals. So of course, we intend for you to be able to recognize the type of weathering process at a glance of a chemical equation, and then explain metamorphic process in mineral transformation, and then list the main factors that triggers chemical weathering, and finally we are going to illustrate the formation of valley as well as the formation of the river. So to start with, let us first have a glance on what is geomorphology. So lithosphere as the utmost earth layer is characterized by many depressions and elevations. You know that. And such characteristics are the results of a geomorphological process occurring continuously on Earth's surfaces, thus creating various types of landscape within geosphere and hydrosphere. So as you can see in the slide, there are various or limitless geomorphic features or landforms on Earth, and that is actually because of the geomorphic process. Well, geomorphology is the study of the nature and origin of landforms, particularly of the formative processes of weathering and erosion that occur in the atmosphere and the hydrosphere. So the word geomorphology derived from the Greek. Geo means earth, form, and logos, the study. And thus it is the study of scientific study of landforms and the processes that shape them. So it is also a composite science. Of course, the study of landforms, including in recent times, especially investigations into processes that cause and alter the landforms. Geomorphology is practiced within physical, geography, geology, geodesy, engineering geology, archaeology, and geotechnical engineering. Well, geomorphology is a basic criteria on some hazards. When we deal on hazards or natural hazards or geological hazards like earthquake, landslide, and liquefaction, we intend to have to deal with geomorphology. Okay, what is geomorphology all about? All you can see on the physical process, physical attributes of the site is actually geomorphology. So what is the form? What is the layer? What is the height? What is the cut? What is the geology, the shape or the geometry, the angle of slope, etc. So those are the practical criteria that we need to know as an engineer. So as I have said, there are limitless land formations and surface alterations. So what you can see a million years ago or perhaps 20 years ago would be different from the present time. Okay, so meaning the surface features or land formations will tend to alter as time goes on. Okay, why geomorphology? So to understand geomorphological processes of various environment. So from this we can also detect the natural and environmental hazards efficiently, like earthquake, flooding, landslide, tsunami, volcanism, etc. And then to identify various landform features and landscapes. Then to identify also various landforms features from the satellite images. Then coastal and river research and vulnerability study. So geomorphology is not only taken on site itself, but it can also interpreted on top view. So normally hazard mapping could be interpreted on top through satellite images so that you can have a relevant information on the geomorphology so that you can integrate it on your hazard design or design of mitigation measures, as well as the magnitude of the hazard that it would take. So what are the processes work behind the landforms? So geomorphic process, the process responsible for the formation and alteration of the Earth's surface. It is also the physical and chemical interactions between the Earth's surface and natural forces acting upon it to produce landforms. So later on we will deal with that. And then the processes are determined by such natural environmental variables as geology, climate, vegetation, and base level, to say nothing of human interference. Now we would like to emphasize here that the geomorphic process is all about natural process. So we will disregard the human interference because as humans sometimes geomorphic process are accelerated because of alterations. So of course we have the equipment, we have the tools, and we have the capability to do it, but the geomorphic process is all about the natural. So we will just have to consider natural processes. So we set aside yung mga human interventions like cutting of slopes, excavation works, and then tunneling. So for the meantime, we will disregard that one in our discussion. So the geomorphic processes are all those physical and chemical changes which effect a modification of Earth's surgical form, that is according to Thornbury in 1968. And then it is also a process by which the Earth's landforms are changed or maintained, according to Gardner in 1979. So here, the figure shows the breakdown of geomorphic processes. So geomorphic processes could either be terrestrial, or processes are just within Earth's lithosphere. Of course, yung extraterrestrial naman yan, so this includes the influence of yung mga heavenly bodies that enters the Earth. Of course, when it enters the Earth, it would have an impact because of the gravity, okay, factor of gravity. So exogenetic processes are outer processes that are influenced by above factors. What are those factors? Temperature variations, of course. May mga malalamig na climate on different locations, and there are extreme warm conditions or climate. So those temperature variations will affect the earth materials that lies within the Earth's core. Okay? And then aside from those factors, meron din tayong gravity. Of course, this gravity has something to do with the erosion, degradation, as well as transportation. So precipitation is also a factor, and other geological agents, which we will have to discuss sooner. Okay? So these factors initiate processes of weathering, erosion, transportation, yung mga deposition, denudation, etc. Yung mga exogenetic factors naman and processes could also have sources outside the Earth, for instance, under the influence of the sun and the moon, etc. So the above mentioned processes constitute essential landform shaping factors. So ito yung mga nagsishape ng land features. Okay? So those mentioned. So types of geomorphic processes. We have from the diagram, ito naman natin, terrestrial and then extraterrestrial. So as an example, we have the fall of meteorite, so mass or rock from the outer space. And the terrestrial process, we have the exogenetic and endogenetic. So when we say exogenous process, exo means outer geomorphological process. So such process includes solar radiation, wind, temperature changes, water. So it creates relief sculptures and surface feature. So along the way, kaya nga may tinatawag tayong weathering process. This is a type of process wherein there is an alteration of the chemical composition of your material. So when this happens, yun, nagdi-decay, and then eventually it will erode, it will break, okay, through that process, and it creates yung mga parang hinubog siya, or sculptures and other surface features. So another type is endogenetic process, in which this is the inner geomorphological process. So, endogenetic process. Bakit inner? Because we are dealing with the inner core. So, the core just below your outer core, no? So, we will have a discussion on phenomena like earthquakes, volcanoes, folding and faulting. Of course, we have a preliminary knowledge on these ones because these are discussed on the previous lectures. So these create rough features of Earth's relief like oceanic basins, mountain ranges, oceanic ridges and trenches, reef valleys, faults, and volcanoes. So practically, if we can see here in the figure, pag sinabi nating endogenetic, ano yun, sa inside. Okay, so it is an inner process. Why it is inner? Because the process involves inner phenomena, no? So, ito yung mga layer below. And then, when we say exogenetic, it is the outermost layer that is happening. Okay? So, that is the difference between endogenetic and exogenetic process. So, yun. On endogenetic process, we have mga volcanism, earthquake, and landslide. Ito yung tinatawag na catastrophic events in which kitang-kita natin ang effect on Earth's surface. And it could be recognized immediately. Okay? While comparing it to yung faulting and folding, diastrophism and metamorphism, it is described by its slow movements, no, where changes occur in a very gradual manner, so very slow. So with this, changes are hardly recognized. Okay. So the basic difference between the two processes that are caused by forces from within the Earth are endogenous processes. By contrast, exogenous processes come from forces on or above the Earth's surface. So, endo, inner, exo, outer. Okay? So, further, with the comparison, endogenetic process originate in the interior of the Earth, while exogenic process originate on the surface of the Earth. And then endogenetic, it causes sudden or rapid movements, while that of exogenic process causes slow movements. So, example ng endogenetic. Kapag sudden or rapid movement, what are those endogenetic process, So, ano ba yung mga interior phenomena? Nandyan na. Earthquake, faulting, diastrophism. So, diastrophism, ito yung faults and folds that we have actually discussed. And then, those examples, kitang-kita naman natin, or we have a quick recognition of the effects of earthquake, faulting, and diastrophism. Kapag nangyari yun, pag lumindol, kitang-kita natin yung effect. Okay. So, exogenetic process, slow. Ito yung mga erosion. Yung erosion, hindi tulad ng landslide na volume, ano? So, erosion is um, very gradual mobilization of your sediments. Why? Because of gravity. So, erosional and depositional. So, endogenetic process is further broken down into some processes here. So, it is broken down into slow movements and sudden movements. So, the sudden movements, we have volcanism and earthquakes. And the slow movements, we have the diastrophism. So, diastrophism could be either vertical movements and horizontal movements. So, it is termed na yung sa vertical is EPEIROGENIC, or it is actually the building of the continents. And when we have a horizontal movement, it is orogenic, or the building of mountains. So, mountain formation yan. Okay? So, sooner, by and by, I will elaborate that further. Okay? So, of course, when we say vertical, we will be having two movements only. We have either upward or downwards. And then, if we have horizontal movement, syempre, the continents or the plate will be either compression or convergent, or if we have a tension, it will be divergent. So compression will cause fault mountains, while that of force of tension could cause fault mountains or a rift valley. So let me describe here the first process under endogenetic processes. So first, we have the diastrophism. So actually, na-discuss na natin to. It is just a process, yung faulting and folding. So diastrophism is also called tectonism. Large-scale deformation of Earth's crust by natural processes, which leads to the formation of continents and ocean basins, mountain systems, plateaus, rift valleys, and other features by mechanisms such as plate movement, volcanic loading, or folding. So again, the internal forces would be active on this process. So on metamorphism, let me first fix this one. This is the change in rock structure, minerals, or geologic structure. It is a process of change in physical structure of rock as a result of long-term heat, pressure, and introduction of chemically active fluids, especially a change that increases the rock hardness and crystalline structure. So the change occurs primarily due to heat pressure, and the introduction of chemically active fluids. So alam naman natin the main feature of metamorphism is actually the high temperature. So we all know that underneath the outer core, we have the magma. So from the magma, we will be having a melted element that is in the form of the igneous rock, and later on this igneous rock will solidify as it cools down. And then there are a lot of chemical weathering going on that process. So later on we will have the details on it. Okay. So the following are processes along diastrophism. First we have orogenic process, EPEIROGENIC processes, minor movements caused by earthquakes, crustal plates, horizontal movements caused by plate tectonics. So let me reiterate yung number 3, minor movements. Kasi nga sinabi natin na yung endogenetic are a slow process. Okay? So we have included here minor movements. Kasi kung yung earthquake is a major movement, that will be catastrophic in nature. Okay? So the consideration in diastrophism here is just a minor movement caused by the earthquakes. So let us have EPEIROGENIC movement description. So EPEIROGENIC comes from the Greek word epeiro, which means land, and then genesis, which means origin. So the root word itself defines it as the origin of land. Okay? And then it is upheavals or depressions of land exhibiting wavelengths and little folding apart from broad undulations. So when we say undulation, it simply means the action of moving smoothly up and down. Okay? So smoothly. So remember the two plates which is convergent to each other, no? So this is a classic example, no, between the continental crust and oceanic crust, as we have discussed previously. So oceanic crust, we have a denser material called basalt, and the denser material would tend to slip over the soft yosemite, or what we call the granite material of the continental crust. Okay, so on the slide we can see EPEIROGENIC movements that is permanent, because EPEIROGENIC movement can be either permanent or transient. So when we say transient, it is simply come and go, no? Transient. So permanent uplift can occur when igneous material is injected into the crust. Okay? So we have circular or elliptical structural uplift, ano? So the tendency, iaangat niya yung nasa ibabaw. Okay? So we will have uplift over a large radius. So it is about tens to thousands of kilometers. So this is actually one characteristic of a mantle plume. So, yung mantle plume, yung meron siyang pathway of a vertical pathway of magma that is exiting your outer core. Okay, so that is a mantle plume. So how about EPEIROGENIC movement that is transient? So we say that transient is come and go, ano? So transient uplift can occur over a thermal anomaly due to convecting hot mantle. So kung nawala yan, the convection will disappear. Ganun din yung uplift will also stop. So why is it that it is anomalous? We can see here in the slide that this is the shape of your magma, and because of this magma, the hot portion will tend to go up and the colder one will tend to go down. So let me elaborate yung process ng convection current, ano? Paano ba nagkakaroon ng convection current? So as we can see here, this will tend to go up. Okay, so those water elements that are nearer to the hot region will tend to go up, and then it will pull the colder one. Okay, so pag tumaas yung tubig na yan, papasok na yung mga malalamig dyan. Okay, so ganun din, pagpasok ng mga malalamig, iinit din yun, tataas, and then parang cycle. Okay, so it will go around in a round waves. Okay, so kung nangyari yun, of course, we have the EPEIROGENIC movement. And from that, kapag nag-cool down na lahat, or if all of those water would have the same temperature, doon na mag-stop yung convection current. So it is formed because a heated fluid expands. So magiging less dense yun, and then the less dense heated fluid rises away from the heat source. Okay? So kapag tumaas yun, as it rises, it pulls cooler fluid down to replace it. So yun. Yung pumunta dun sa baba, tataas din ulit. And then again, it will pull cooler fluid to replace it. So this fluid in turn is heated, rises, and pull down more cool fluid. And this cycle actually establishes a circular current. Ito hihinto lang when the heat is evenly distributed throughout the fluid. So a classical example, if you know yung radiator ng sasakyan, a hot radiator hits the air immediately around it. The air rises towards the ceiling and then pulling cooler air down, then from the ceiling into the radiator to be heated. So this process repeats until the air in the room is evenly heated. So meron nga yung water reservoir connected to the radiator, doon umiikot yung tubig. Okay? So that is a similar process on that EPEIROGENIC movement that is transient in nature. So we have here now notable results of EPEIROGENIC movements. So EPEIROGENIC movements may divert rivers and create drainage divides by unwarping of the crust along axis. So an example of this is the deflection of Eridanus River in the Pliocene epoch by the uplift of the South Swedish Dome or present-day drainage divides. Ito another example between Limpopo and the Zambezi rivers in southern Africa. So, una, meron tayong tinatawag na Eridanus River. Nawala, biglang nawala, na out of picture. So, the name of Eridanus derived from the ancient Greek. Eridanus was given by geologists to a river that flows where the Baltic Sea is now, and its river system was better known as the Baltic River System. So Eridanus began about 40 million years ago, okay, in Eocene. Then by about 12 million years ago in the Miocene, the Eridanus had reached the North Sea area, where the sediments carried by the river built an immense delta. So yung delta is the point of intersection between the ocean and the river. Okay? So ngayon, this river disappeared in the early middle Pleistocene, about 1 million years ago. Okay? When the Ice Age glaciers excavated the Baltic seabed. So, yung glaciers has something to do with it. So, it has deepened the Baltic seabed. And then, the Neogen uplift, okay? Tinaas niya yung South Swedish Dome, which, kapag tumaas, dinivert niya yung tubig. So, it deflected the Eridanus River from its original path across the south-central Sweden into a course of Sweden in the Pliocene era. Okay? So, that is the story behind the disappearance of the Eridanus River. So, another notable results of EPEIROGENIC movement is the decreased drainage area of the Limpopo River. So Limpopo River rises in South Africa. So generally, it flows eastwards through Mozambique to the Indian Ocean. Okay? The first European to sight the river was Vasco da Gama, who anchored off its mouth in 1498 and named Espiritu Santo River. So its lower course was explored by Saint Vincent Erskine in around 1868 to 1869. Okay? So the drainage area of this Limpopo River has decreased over geological time up to late Pleistocene times. So why? The upper course of the Zambezi River drained into Limpopo River. So the change of the drainage divide is the result of a EPEIROGENIC movement that uplifted the surface north of present-day Limpopo River. So yung north portion, tinaas niya. That is why there is a decreased drainage area of the Limpopo River. So, diverting waters in Zambezi River. Okay. So moving on. So the contrast of EPEIROGENIC movement is this, OROGENIC movements. So kung yung EPEIROGENIC movement is about a vertical movement, ito naman OROGENIC movement is about horizontal movement. And from orogeny, this is actually a mountain building event, generally one that occurs in geosynclinal areas, where it is in contrast to EPEIROGENY. So it tends to occur during a relatively short time in linear belts and results in intensive deformation. Okay. So we have here faulting. We have actually discussed this one. And folding. So these two are sub-process of orogenic movement because it is a horizontal movement. So it could be that faulting will occur on a normal condition. So alam naman natin kapag normal, the force is a tensile one. Okay, why normal? Because we have turned normal faulting to incorporate the normal reaction of the block that is hanging on the footwall of this footwall of this fault plane. Okay, so meron tayong tinatawag na footwall kung saan yung hanging wall is resting on that. Okay, and the hanging wall nakapatong sa footwall. Okay, or meron din tayong tinatawag na reverse faulting. Kapag reverse faulting, yung nakahang will tend to go up because the force is in compression. Okay, we also have the thrust folding. Kapag thrust folding, your fault line is not a diagonal one, but it is a vertical one. So if that is the case, the rupture between the crack section will be a slip. Okay, a slip action between the two. So yung fold naman, so as a review, meron tayong tinatawag na syncline. The syncline is a portion where it is the lowest point on the concave. Okay, and then the anticline is the highest point of the concave caused by the folded rock. So fold is an undulation or waves in the stratified rocks of the Earth's crust. So it occurs when one or mass of original flat and planar surfaces are bent or curved as a result of permanent deformation. So this is more on plastic deformation. Okay, kasi nga instead of breakage, it has bended. Okay, and then from the compressive force, the resulting land land formation, specifically on orogenic movement, is fold mountains. Okay? So, magkakaroon tayo ng fold mountains. And why is that? So, from the subduction zones, so the denser material will tend to go down, and then there will be a push. Okay? There will be a push on that. At the same time, mayroong exit ng hot material dito, will tend to melt your material, and then it will go upwards, and then eventually it will exit. So kaya nga, let us note here that fold mountains normally is a volcanic mountain range. So you can see in the diagram, yan, bumaba yan, then there will have an exit here on this portion. So the continental crust and the lithosphere are the involved layers. So pwede rin mangyari to between oceanic plate and continental plate. Okay. So fold mountains are actually formed by compressional forces resulting to bending of rock layers. So this would take time, no? So this process would take time kasi kapag sudden yan, of course, kapag mabilis yung loading, tapos transient siya or come and go, rock is a brittle material, you know that. And because of that, a quick application of the force will tend to have a breakage. So instead na fold yan, magiging faults. Okay? So yung fold, it will form through a slow pace of formation, very gradual. Okay? So as an example of fold mountains, we have here a close view of a folded mountain. Ito yung the Alps, ano? So roughly mark the top of the boot of the Italian peninsula. So ito matatagpuan siya sa Italian peninsula. So kasi yung Italian peninsula, it is on the shape of a boot on the map, as you can see. So on top of that are the Alps. Okay, kaya tinatawag siya na top of the boot of the Italian peninsula. So the Alps stretch across Italy, Slovenia, Austria, Germany, Switzerland, Liechtenstein, Monaco, and France. Here, the tiny Adriatic microplate is colliding with the much larger Eurasian plate to the north. The J-shaped Adriatic microplate is a remnant of the African plate to the south, and today it carries the eastern Italian peninsula as well as the entire Adriatic Sea. So alpine geology includes sedimentary and metamorphic rock as well as igneous rock that once were part of the ocean floor and were later uplifted in the process of folding. So that's the story of the Alps. And then another fold mountains is the popular Himalayas. The Himalayas stretch through the borders of China, Bhutan, Nepal, India, and Pakistan. So the crust beneath the Himalaya, the most towering mountain, yung pinakamataas sa buong mundo, is still on the process of being compressed. Okay? Until now, nako-compress yan. That is why patuloy pa rin siyang tumataas. Here, the Indian plate is colliding northward with the Eurasian plate. The sedimentary rocks of the Himalayas include ito mga material, shale and limestone. So yung mga metamorphic rock on the region include the schist and gneiss. So dikes of igneous rock also intrude throughout the rock formations of the Himalayas. Okay, so folded mountain yan. And then we also have the Andes Mountain. So kung yung Himalayas, yun yung pinakamataas. Yung Andes naman is the longest mountain range in the world and boasts some of the highest peaks. Okay? So it is also known for its volcanoes, ruins of long ago civilizations, and the source of a malaria treatment. So kaya nga dito merong picture, merong dati yung civilization. Okay? So it is noted na napakaraming vulkan dyan. Okay? So it is located along the entire western coast of South America. So the Andes mountain range is about 7,242 kilometers long. So napakahaba. So the mountain range spans 7 countries: Venezuela, Colombia, Ecuador, Peru, Bolivia, Chile, and Argentina. So imagine that long, nako-cover niya pa yung 7 countries and can be found between 10 degrees north and 15 degrees 57 degrees south latitude. Okay? Ito, pangalawa siya sa pinakamataas because the only mountains that are taller than the Andes are the Himalaya mountains. So another important geologic feature of the Andes, it is the home to the world's highest volcano when measured above sea level. So yung highest volcano nandito rin. So yung volcano, there are more than 50 volcanoes that reach 6,000 meters. So napakataas na volcano, hindi lang isa. No? So more than 50 volcanoes. So we have noted a while ago dito, normally fold mountains are volcanic mountain range. We can see it, or we can observe it on the Andes mountains. Okay, so that is due to a compressive force. Moving on, we have land formations due to tension. So this will result to Rift Valley. So we can see here on our slide figure, there are 4 stages. No? Stage 1, magwa-warp muna yung lithosphere. Okay? So wala pang separation. So it is the beginning of the formation of divergent plate boundary. So as we can see on the arrow, divergent, maghihiwalay. Okay? So pulling the plate are pulling one another. And then stage 2, formation of a rift valley. This is the East African Rift Valley, is at this stage. Okay? So meron ng separation. And from that, lalawak ng lalawak yung separation. On stage 3, there will be a formation of a linear or narrow sea. An example is the Red Sea. Okay, is at this stage. And then final stage is the formation of the ocean, a well-developed mid-oceanic ridge, active crust formation. All major oceans are at this stage. Okay. So as an example for this, we have a big crack on East African Rift Valley as stated on the stage 3. No? So when the lithosphere is subject to a horizontal extensional force, it will stretch. So kapag ni-stretch yan, ninipis, eventually it will rupture, leading the formation of the Rift Valley. So this process is accompanied by surface manifestations along the Rift Valley in the form of volcanism and seismic activities. No? So rifts are the initial stage of continental breakup, and if successful, can lead to the formation of the new ocean basin. So maghihiwalay yan, it will result to a new ocean basin. So basically, yung tinatawag na continental rifting or the Rift Valley requires the existing of extensional forces great enough to break the lithosphere. So this example, or itong East African Rift, is described as an active type of rift in which the source of these stresses lies in the circulation of the underlying mantle. Sabi nga natin kanina, yung mantle convection, may mga nagsisirculate na tubig because of the hot layer. So beneath this rift, the rise of a large mantle plume is doming the lithosphere upwards, causing it to weaken. Okay? As a result of the increased temperature, may stretch yan and eventually rupture, and it will break by faulting. So as you can see, napakalaki ng crack. So this implies a separation of two large continents. So another rift valley is the VINDHYA and the SATPURA Rift Valley. So as we can see in the slide, okay, India was made by these three plates, and then when these three plates were collided, then there was a formation of a mountain. They are fold mountains, and they are created by forcing of plates on either sides. Okay? Pag nag-collide, of course, magiging ano yan, bundok. And the gap between the VINDHYA and SATPURA is the Rift Valley. So yung gap between these mountains are the Rift Valley, and the river, yung tinatawag na River Narmada, is passing between them. So here is the picture of it. Okay. So next, so another Rift Valley is formed by sinking of rock strata lying between two almost parallel faults is the Nile Valley. So the Nile River is the longest river in the world. So it is called the father of African rivers. Okay. So a new study finds evidence that supports yung theory nila about this formation of Rift Valley. So the Nile River may have emerged around 30 million years ago, driven by the motion of Earth's mantle. So the thick layer of rock between the Earth's core and crust. So nag-simulate yung mga scientists, and as a result, it showed that a hot mantle plume, an upsurge of extremely hot rock in the mantle, pushed the ground upward. So, tinulak niya pataas and then creates the Ethiopian highlands and also activated a still existing mantle conveyor belt that pushes upward the Ethiopian highlands in the south and pulls the ground in the north. So this creates a northward slope on which the Nile still runs until now. Okay, so those are examples of rift valley from orogenic movements. Okay, so to wrap our discussion, so let us have some technical terms here. Okay, the graben and horst. So rift valleys with steep parallel walls along the fault are called graben. So ito yun. Okay, so graben would be the flooring of your valley. Okay, and yung tumaas na portion of the landmass is the horst. Okay, so graben, so yung mababang portion, and the horst are the uplifted landmass. Okay, so the very steep slope in a continuous line along a fault is termed as escarpment. Okay, so yun. So the valley formation, kitang-kita mo yung boundaries of the valley will be viewed on the escarpment. Okay, so I think we have to continue next meeting for the phase 2 of your lecture. So thank you for listening and have a good day.